Dear students, in this lecture, we will discuss about analysis of series RL circuit excited by AC circuit. So, a circuit that contains a pure resistor is connected in series with a coil having a pure inductor. Inductance is measured by Henry is known as RL series circuit. So, a circuit consists of series combination of resistor and inductor is known as RL series circuit. When AC supply is applied across this circuit, AC supply V equals to applied across this circuit, then current I will be flowing through the circuit. Then current flowing through the resistor IR and current flowing through the inductor IL will be the current in resistor and inductor respectively. And the amount of the same amount of both are connected in series, so that see the same amount of current is flowing through the both the elements. Why? Because both are connected in series. So here there is a series combination of resistance and inductance. So the voltage drop across resistor is taken as VR and the voltage drop across inductor is taken as VL, and current flowing through the both the resistor and the inductor is the same. Why? Because both are connected in series, and this both series combination of resistor and inductor both are excited by AC supply V equals to Vm sin omega t. So VR is the voltage drop across resistor, VL is the voltage drop across inductor, V is the total applied voltage. So we will draw the phasor diagram of RL series circuit. First of all, we should follow the following steps to draw the phasor diagram. The current is taken as reference phasor. This is the current is taken as reference phasor, and voltage drop across resistor. As we know that voltage drop across resistor is always in phase with the current. So that voltage drop across resistor is always we should draw in phase with the current VR. And voltage drop across inductor VL equals to I into XL. XL is nothing but inductive reactance, is nothing but resistance of the inductor, denoted by XL. Inductive reactance is a drawn head of current. So voltage leads by in pure inductor, voltage leads current by 90 degrees. So in this way, voltage drop across inductor leads by 90 degrees. So voltage leads by current by 90 degrees. Here 90 degrees will make, and the vector sum of VR and VL will give the total applied voltage V, so that from the right angle triangle OBA, as per Pythagoras formula, V equals to square root of VR square plus VL square, square root of root over VR square plus VL square. So VR equals to I into R, VL equals to I into XL, I into R, current into resistance of the resistor, voltage drop across resistor. Similarly, voltage drop across inductor equals to I into inductive reactance of the inductor. As we know that XL equals to 2 pi FL. So in this way, this vector VL and this vector VL both are same. This is parallel to this one. So as we know that from the Pythagoras formula, V equals to square root of VR square plus VL square. VR equals to, by substituting VR equals to IR whole square plus IXL whole square. By taking the I is taken as common, V equals to I of square root of R square plus XL square. So from V by I is nothing but Z. V by I is nothing but Z. So that Z equals to RI equals to V by Z. RI equals to V by Z. R V by I equals to Z. So Z equals to this term, remaining term. Z equals to square root of R square plus XL square. So for series RL circuit, impedance is defined as square root of R square plus XL square root over. V by I is nothing but we know that impedance is also defined as ratio of voltage to current. Z equals to V by I. V by I is nothing but Z. Again Z equals to square root over R square plus XL square. For series RL circuit, impedance formula is square root of R square plus XL square. So Z is the, as we know that total opposition offered to the flow of alternating current in a series RL circuit is called as impedance. It is measured in ohms. How will you calculate? How will you calculate phase angle? Means from the phasor diagram, RL series circuit current lags the voltage by 90 degrees is known as phase angle. So it is tan phi equals to, from the phasor diagram, this is VR, this is VL, this is applied voltage V. Applied voltage V. So from the phasor diagram, tan phi equals to opposite side by adjacent side, VL by VR. VL is nothing but IXL divided by IR. So II will get cancelled, XL by R. So tan phi equals to XL by R, imaginary term by real term. XL is nothing but, as we know discussed in previous lectures, XL equals to inductive reactance, XL. So XL by imaginary term by R, real term. So phi equals to, phase angle phi equals to tan inverse XL by R. In this way, we will calculate phase angle. Phase angle phi equals to tan inverse XL by R. Now we will see the power in RL circuit. We will see the power in RL circuit. As we know that in series, combination of RL circuit is excited by AC voltage. V equals to instantaneous voltage. V equals to Vm sin omega t. That can be also written as Vm at an angle 0 degrees. So the current equation is given by, for RL circuit, as we seen in pure inductor excited by AC supply, as we seen that I equals to Im sin of omega t minus pi. So current equation equals to I equals to Im sin of omega t minus pi. The instantaneous power equals to product of voltage and current. So instantaneous power equals to, it is denoted by always instantaneous values, always represented by small alphabet. So P equals to V into I. So putting the values in, value of V and value of I, by substituting the voltage and current in equation, above equation, P equals to VI, Vm sin omega t into Im sin omega t minus pi. So Vm into Im into sin omega t minus pi. So by multiplying 2 and divided by 2, Vm Im by 2 into 2 sin omega t and 2 sin omega t. This it look like 2 sin A sin B. It look like 2 sin A sin B. 2 sin A, this is sin A, this is sin B. 2 sin A sin B formula equals to cos of A minus B minus cos of A plus B. So by substituting the formula in cos of A minus B minus cos of A plus B, Vm Im by 2 can be written as Vm by root 2 into Im by root 2. This is the, it look like 2 sin A sin B formula. By substituting the equation in cos of A minus B minus cos of A plus B, we will get the cos pi minus cos of 2 omega t minus pi. So finally, so Vm by root 2 Im by root 2 into cos pi minus Vm by root 2 into Im by root 2 into cos of 2 omega t minus pi. So this is the instantaneous power for a series RL circuit. I want to calculate the average power. So as we know that average power is obtained by integrating the instantaneous power over a cycle. Integrating the instantaneous power over a cycle. So that, so for completion of one cycle, integrating the complete one cycle, average power will be obtained, integrating the instantaneous power over a one cycle. So P of average of Vm Im by root 2 Vm Im by root 2 cos pi minus average of Vm by root 2 Vm by root 2 Vm Im. This is not Vm, here Im. Similarly, this is also Im cos of 2 omega t minus pi. As we know that by integrating the any sine function or cos function, by integrating the any sine function or cos function for a complete cycle, as we seen in pure inductor excited by AC supply, pure capacitor excited by AC supply, by integrating the any sine or cos function over a complete cycle, it will go to zero value only. It will be zero only. So that remaining term Vm by root 2 Im by root 2 into cos pi. Vm by root 2 is nothing but Vrms. Im by root 2 is maximum value by root 2 is nothing but RMS value. So Vrms into Irms into cos pi. So Vrms Irms basically our notation is all voltage or current or power values are represented in RMS values only. So VI cos pi. So where pi is the power factor, phase angle between pi is the power, cos pi is the power factor, phase angle between voltage and current. So from the phasor diagram, cos pi equals to adjacent side by hypotenuse, VR by V. So VR is nothing but I into R, V equals to I into Z. So I will get cancel, R by Z, cos pi equals to R by Z, or VR by V. We can utilize any these three formulas based upon the given data. Cos pi will be calculated by using VR by V or R by Z or IR into IR by IZ. So the power factor is defined as a ratio of resistance to impedance, ratio of from resistance to impedance. So in this way, we will analyze the series combination of RL circuit by using analysis of series RL circuit excited by AC supply. Thank you.